Welcome learners to question 26 Kcse 2022, that is chemistry paper 1. We have hydrazine, which is a fuel, is used as a fuel in rockets. Using the bond energies in table 2, calculate the enthalpy change for the combustion of hydrazine. We have the equation for the combustion, where 1 mole of hydrazine combines with 1 mole of oxygen to produce 1 mole of nitrogen gas and 2 moles of water. So in the calculation of the enthalpy change for the combustion of hydrazine, we have to start by identifying the types of bond present in hydrazine, the bonds present in oxygen, that is the reactant side. So hydrazine, we have 2 nitrogen atoms, and then we have a total of 4 hydrogen atoms. This is what we call hydrazine. 1 2 3 1 2 3. Then it's added to oxygen. This is how we write oxygen gas. So let us deal with this side, the reactant side first, and then we shall move to the product side later on. So how many bonds can we see? We can see one nitrogen bond. So we have only one nitrogen bond. We can also see nitrogen hydrogen, that is 1, nitrogen hydrogen 2, nitrogen hydrogen 3, nitrogen hydrogen 4. So we have 4 nitrogen hydrogen bond. We only have one oxygen double bond, oxygen, so we say plus only one oxygen molecule bond. So we have the enthalpies for these bonds. The bond between nitrogen and nitrogen requires 163 to be broken down. So we have I have 163 plus 4 into nitrogen hydrogen bond. It's 388, and then plus the only one oxygen bond, which is 496. So if I have these values in my calculator, we shall have a total of 2211 kilojoules per mole. Remember, this is bond breaking. These are the bonds which are broken in this particular reaction. So what happens? Bond breaking is always endothermic, and that is why we have the positive sign. Now let us move to the products. On the product we have nitrogen. On the product we have nitrogen gas and 2 molecules of water. So nitrogen gas contains the triple nitrogen bond because it has 3 electrons, so it provides 1 electron in bonding, also provides 1 electron in bonding to give us 1 bond. The second electron gives us the second bond, and the third electron each forms the third bond. Remember, they form covalent bonds. Bond formed as a result of sharing electrons, and the shared electrons are donated by each of the combining species. And then we have the hydrogen in water. We have oxygen hydrogen. So inside here we have oxygen hydrogen, that is 1, oxygen hydrogen another bond, so we have 2 oxygen hydrogen bond. But how many molecules of water do I have? I have 4. So we can simplify it and say nitrogen triple bond, its energy is 944, and then plus 2 into oxygen hydrogen bond 463 plus oxygen hydrogen bond 463. There are 2, and that is why we have 463, and then we multiply by 2 because we had 2 moles of water molecule. So 944 plus 263, it's 463 plus 463, and then you multiply by 2, you come up with 1852. If we add this, we shall have a total of 2796. Now, because this is on the reactor, on the product side where new bonds are formed, we talk of bond formation. Bond formation is always exothermic, and that is why we need to have that particular sign, the negative sign, showing that this particular reaction releases heat energy to the surrounding. Now we have the first, that is the energy for the bond breaking, and then we have the energy for the bond formation. So the enthalpy change, or rather the enthalpy change for combustion of hydrazine, will therefore be, we shall talk of bond breaking, and then plus bond formation energies. The bond breaking energy was positive 2211 plus minus 2796. The bond formation enthalpy, so 2211, and then I add negative 2796, we shall have negative 585 kilojoules per mole. So meaning the enthalpy of combustion of hydrazine is an exothermic reaction, because its overall enthalpy change is negative 585 kilojoules per mole.